Welcome! In this video, we will learn how to use XLMiner to perform linear regression. Assume that you already have XLMiner properly installed on your computer. Throughout the video, I will use the Boulder housing dataset. I will first demonstrate how to build a simple regression model with one predictive variable, and then proceed to show you how to build a multiple regression model with more than one predictive variables. We'll also talk about interacting terms and transformations as ways to improve the regression models. At the end, I will show how to use XLMiner to partition the dataset and perform cross-validation. Here is the Boulder housing dataset we discussed before. The data has many columns. To perform a simple regression, we're going to use two columns. List price is used as the target variable, and square feet is used as a predictive variable. If you have XLMiner properly installed, you should see the XLMiner ribbon when you bring up Excel. To perform regression, click on Predict and Multiple Linear Regression. Note that all variables are listed here. Choose square feet and move it to selected variables, and set list price as output variable. Click Next. You will see a number of options. We skip them for now and click Finish. This creates two new output sheets in the Excel workbook. Let's take a closer look at the output sheet named MLR Output. At the top of the window is Output Navigator, which can lead you to different sections of the output. Let's scroll down to the regression model section. As we can see here, the coefficient estimates are -124 and 0.4268. This table also gives us the p-values, which are pretty small for both coefficients, indicating that the model is statistically significant. There are some additional summary statistics in the table on the right. In particular, the R-squared 0.64, meaning that 64% of variations in list prices are explained by the model. The RSS, or residual sum of squares, is 97901,628. This number is also called sum of squared errors. This last number is also reported in the training data scoring section below. Building a multiple regression model follows almost the exact same steps. Let's first return to the worksheet with the data. Click Predict and Multiple Linear Regression. Excel actually remembers our previous selection. Let's add parking type to the selected variables. Click Finish. Excel creates another two sheets with an updated output. Scroll down to the regression model section in the output sheet. Here we can see the multiple regression output. Because we have two predictive variables, we have one additional coefficient estimate. The coefficient estimate for parking type is -99.56, indicating that the value of garage parking is around -$99,000. This is quite surprising and is likely caused by multicollinearity. Recall that multicollinearity occurs when two predictive variables are correlated. For our dataset, it just so happens that larger houses are more likely to have garage parking. There are several different ways to improve a linear regression model. We discussed two of them here. The first one is interacting terms, or mathematically, simply the multiplication of two terms. To introduce an interacting term between parking type and square feet, we add one more column to our dataset. Let's return to the worksheet with original data. We'll call our new data column square feet times parking type and type it in the first empty cell in column K. Move the cursor to the next cell in the same column and type a formula that multiplies square feet and parking type. Fill down the formula in the column to create the value of the interacting term for all rows. To build a new model with this interacting term, click Predict and Multiple Linear Regression. In the pop-up window, our selections before are still there. However, the interacting term does not appear in the available variables. This is because the data range ends in column J. Go to the data range input and change J to K. Observe that now the interacting term is available. Move this new variable to selected variables and click Finish to get the results. Now there are four coefficient estimates. In particular, the coefficient for the interacting term is 0.0169. Next, let's briefly discuss data transformation. We apply a logarithm transformation to the list price and square footage variables. This can be done by adding two data columns. Go back to the worksheet with the data. Now, in column L, create a variable called log price. Type the name of the column log price in the first empty cell in column L, and type the formula log A2 in the next cell in column L. In column M, create a variable called log square feet. In column M, create a variable called log square footage. type log square footage in the first empty cell and type the formula log B2 in the cell on the next row. Select the two cells on the same row and fill down to create the variables for all rows. To build a new model with the variables we just created, click Predict and Multiple Linear Regression again. In the pop-up window, clear selected variables. Now select log price as output variable and move log square footage to selected variables. If you do not see the variables we just created, remember to update the data range. We obtained a substantially improved model result in the sense that R squared is substantially larger at 0.78, meaning that 78% of the variations in the target variable is explained by the model. Note that residual sum of squared RSS in the output is not directly comparable to the ones we obtained before because the variables are now on the log scale. Our last topic in this video is cross-validation. The first step in cross-validation is to divide the data into training and validation sets. This can be done easily with XLMiner. To do this, click Partition and then Standard Partition. In the pop-out window, we can choose which variables to include. We choose to include all variables by moving them to selected variables. In the bottom, we can set the percentage in training and validation set. We accept the default 60-40 split. Note that you can also choose to set your own percentage, in which case you can divide the data into 3 sets instead of 2 sets, where the last set is called the test set. Click OK brings us a new worksheet with partitioned data. As you can see, there are 188 rows in training data and 126 rows in the validation set. Now that we can bring up the multiple regression window as before, observe that the worksheet is filled with data partition, which is the worksheet we just created. Again, we built a simple regression model with list price as the output variable and square footage as the predictor variable. Compared to the case without cross-validation, now the output contains a summary report for validation data scoring, which is substantially different from the results from training data scoring. The coefficient estimates are also a little different than before. This is because when we perform cross-validation, only the training data is used to build the model. I hope you enjoyed the video. Even though we only discussed relatively simple regression models, we can already see the power of XLMiner. XLMiner also has many advanced features and options not covered here. I encourage you to explore them on your own time.